All right, everybody. Welcome to Mr. Diego Tutoring on Instagram and Crushing IB Chem on YouTube. Today, we're going to crush another IB chemistry question. So stick with me. This is a paper one. So let's crush this IB style question, shall we? All right. This is a redox question, right? An oxidation and reduction. And the question says, in which reaction does H2, so we're focusing on H2, act as an oxidizing agent? So first, we need to know what an oxidizing agent actually is. Well, let's go over that. Right. An oxidizing agent, it's something, a molecule, an element inside a molecule that makes something else oxidize, right? So by definition, an oxidizing agent, every time you see the word agent, it means does that to someone else. So something that's an oxidizing agent makes the other reactant oxidize, okay? Therefore, there's a consequence of that. To be an oxidizing agent, you have to undergo reduction, right? All oxidizing agents are elements that undergo reduction, that suffer reduction, meaning that the oxidation number, or NOx, has to lower, has to decrease, okay? Knowing that there are three possible oxidation states for the element hydrogen. If it's on its diatomic form, like H2, okay? And that is true for all the diatomic elements, okay? If it's on the diatomic form, H2, the oxidation number is 0. Now, there's one exception that will get everyone, and it's the main distractor of this question here, hydrides. Hydrides are a function that involve hydrogen, which consists in a metal plus hydrogen. So we see here sodium hydride, magnesium hydride, and of course they have their own little internal coefficients based on the charge, right? So you have a hydride, and a hydride only happens when you have a metal and a hydrogen with the following coefficients. In this case, hydrogen, if it's a hydride, on hydrides, have the oxidation number of -1. And in all other compounds, literally all other compounds, acids, bases, hydrocarbons, it has an oxidation number of +1. So now let's go back to the question. Notice that in which reaction does H2, that means every single reactant that has hydrogen is H2. Okay, so you got to focus on that. Acts as an oxidizing agent. So therefore undergoes reduction. So it has to lower the oxidation number from the reactants to the product. So let's put a 0 on top of each one because they are all in H2 in the diatomic form, right? Now let's take a look at the products. NH3. NH3 is not a hydrogen because nitrogen is not a metal. It's a Bronsted-Lowry base, right? And it's not a diatomic gas. It is a gas, but it's ammonia. It's a compound. Therefore, hydrogen will have an oxidation state of +1 here. So it went from 0 to +1, and that is an oxidation. So definitely not A. Let's look at B. Hydrogen starts with a 0 oxidation number, again, because it is diatomic. Now, NaH, sodium, is a group 1 metal. Therefore, it's a metal followed by hydrogen. Okay, that is a hydride. Look at the example. Sodium hydride, magnesium hydride, a metal followed by hydrogen right after it, right? So therefore, because this is a hydride, so I'm going to highlight it in green, because this is a hydride, the oxidation number in hydrogen is -1 here. So it's going from 0 to -1. It is decreasing its oxidation number. Therefore, this is a reduction process. Alternative B, okay? Hydrogen, H2, it's only undergoing reduction in alternative B. In HCl, it's +1, and in a hydrocarbon and alkane, in this case, it's also +1. Therefore, the only alternative in which H2 is actually reducing, decreasing its oxidation number is B, because NaH is a hydride, and in hydrides, the oxidation number of hydrogen is -1. All right, stay tuned. Follow my YouTube channel, Crushing Chemistry, and follow my page, Mr. Diego Tutoring. If you want to book a session with me, private tutoring sessions, send me a DM, send me an email, and I'll see you in the next episode. Let's crush some more IB chemistry together. See you later.